What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at the surface area of cones. And luckily for you, we're not going through the proof of how we get to the formula. We're just going to use it in action. So a cone is made up of two shapes. It's made up of the circle at the bottom and then the pointy bit, which is actually a sector. If you do want to find out more about how we work out exactly what shapes these are, I've got a couple of videos linked in the description below that really go into detail of how we get these things. If I was going to break a cone into its net, all it is the circle that's down the bottom and then a sector as well that kind of looks like a Pac-Man. So because of this, we know that pi and the radius are going to be really important for this overall topic. But we've got to make sure which radius is important. So there are three incredibly important measurements for this. We've got the radius of the circle down the bottom. As long as we've got that, we can work out the area of the circle. So that's the major issue. The other thing that we need to know is that we've got two heights. We've got the perpendicular height or the altitude, which I've labeled as h. And then we've got the slant length, which is the height of the actual surface. And distinguishing between these two things is incredibly important. So the formula for finding the surface area of the cone is pi r squared, which is the circle, plus pi rl, and that is the surface area of the top bit of the cone. It's really important here that you notice that that is pi rl, not h. We are not interested in the perpendicular height of the entire cone. We just want to work out how much material is used, so that's why we're using the L. So we're just going to use this formula in action. I want you to find the surface area of this cone. So all we've got to do is substitute in the correct values. We've got pi r squared plus pi rl. So for this, it's pi multiplied by 7 squared plus pi times 7 times 19. That's all you've got to do. Throw those into your calculator and you get the answer of 571.77 centimeters squared. Done. So these ones are not too hard if you've already got the formula memorized. So for this question here, we again have to find the surface area of the cone, but we're given the height or the altitude and not the slant length. So we can't actually use the formula straight away. What we've got to do is find L. So something you might be able to notice is because it's the perpendicular height, so that means at complete 90 degrees from the base, we actually have a little right angle triangle inside our cone. So that means we can use our best friend Pythagoras to get the answer. So L squared, right, which is the hypotenuse, the longest side, is equal to 20 squared plus 15 squared. Make sure you're using 15 squared, not 30, because we're only using half of that circle down the bottom. So 20 squared plus 15 squared is 625. Square root that, and L is equal to 25. Throw that onto your diagram straight away, just so you remember to use that 25 and not the 20. And then we can just use the formula. So this is pi multiplied by 15 squared, the radius squared, plus pi times 15 times 25. So if you throw that into your calculator, you're going to get 1,884.96 centimeters squared, and then you're done. So using the formula here, the only tough part is making sure that you can find L using Pythagoras. Don't just rip in straight away because you see the two numbers. Thanks so much for watching this lesson, guys, and I'll see you later.